Imagine you wake up, and you're standing on the surface of Mars. No spacesuit. No oxygen. Just you, against the red planet. How long before your body gives up? Minutes? Seconds? Or could you actually survive longer than you think? Today on Starsky Science, we reveal the shocking truth about human survival on Mars without any help. And before we dive deep into this extraordinary question, don't forget to subscribe to Starsky Science for more mind-blowing space documentaries that bring you closer to the secrets of the universe. Let's begin with the cold, brutal reality: Mars is not a friendly neighbor. From Earth, it looks like a calm, reddish desert world, glowing faintly in our night sky. But standing there unprotected would feel nothing like gazing at it from afar. The atmosphere is a thin veil of carbon dioxide, about 100 times thinner than Earth's. That means, unlike Earth's thick air that protects us from radiation and keeps our lungs full, Mars offers almost no shield. If you tried to breathe, your lungs would find nothing usable. You'd gasp, but the oxygen just isn't there. Within 20 seconds, your body would start to shut down. But the reality isn't instant death. Scientists at NASA and other researchers explain that human bodies are surprisingly resilient. In vacuum chambers on Earth, when pressure was suddenly lost, test subjects didn't explode as Hollywood movies suggest. Instead, they lost consciousness in about 15 seconds, and their blood started to boil, not from heat, but because the pressure was so low that liquids in the body began to vaporize. On Mars, it's not a perfect vacuum, but it's close enough that your body would begin to experience similar effects. Now, let's talk about the temperature. Mars is cold. Extremely cold. Average temperatures are around -80 degrees Fahrenheit, -62 degrees Celsius, and at night, they can plummet much lower, sometimes to -195 degrees Fahrenheit, -125 degrees Celsius. Imagine standing in that without protection. Within minutes, your skin would freeze, your body heat would vanish into the thin air, and hypothermia would set in. But here's the terrifying twist: you'd actually suffocate long before freezing. Radiation is another silent killer. Earth's magnetic field and atmosphere protect us from cosmic and solar radiation, but Mars has neither a strong magnetic field nor a thick atmosphere. Scientists from the Curiosity rover mission have measured radiation levels on Mars, and they're hundreds of times higher than what astronauts experience on the International Space Station. That means, even if somehow you survived the first few minutes, radiation would begin tearing apart your cells, increasing cancer risks, damaging DNA, and destroying your internal systems. But here's where it gets even more interesting. Could you last longer if you held your breath? Surprisingly, the answer is no. Holding your breath on Mars could actually kill you faster. The air pressure is so low that your lungs would expand and rupture if you tried to keep the air inside. NASA has warned astronauts in training never to hold their breath in case of depressurization, because it causes severe, immediate damage. The only chance would be to exhale and let your body collapse as naturally as possible before blacking out. So, realistically, how long could you really survive? The answer: maybe a minute or two, if you're lucky, before unconsciousness. But total survival without equipment? Impossible. Yet, the details of how your body would shut down are fascinating, and that's where science becomes almost stranger than fiction. NASA scientists once ran simulations to study what unprotected exposure to Mars would look like. The body's moisture, your saliva, tears, even the fluid on your tongue, would start to bubble and evaporate. Your skin would swell slightly, but you wouldn't pop like a balloon. Instead, you'd feel extreme pressure differences inside. Blood vessels close to the surface might burst, leaving red patches across your skin. Within 30 seconds, you'd be unconscious, and within a couple of minutes, irreversible damage would occur. But let's step back and ask a bigger question: why is Mars so hostile in the first place? To answer that, we need to understand the planet itself. Mars is half the size of Earth, and its gravity is only about 38% of what we're used to. That low gravity couldn't hold on to a thick atmosphere over billions of years. Early in its history, Mars may have had oceans, rivers, and even a thicker sky. Evidence from orbiters and rovers suggests that billions of years ago, Mars may have been habitable. But something catastrophic happened. Scientists believe the planet's magnetic field collapsed. Without it, the solar wind stripped away the atmosphere piece by piece, leaving behind the barren desert we see today. Now imagine being left on this planet, alone, without help. Even if you had a shelter, your biggest challenges would be oxygen, pressure, temperature, food, water, and radiation. Every single one of these is a deadly obstacle. And yet, here's the amazing thing, scientists are actively studying how humans might overcome all of them. But before we dive deeper into those survival strategies, let me remind you, if you're fascinated by these kinds of mind-expanding space stories, make sure you subscribe to Starsky Science. We bring you the most incredible, fact-based documentaries every week, so you never miss the chance to explore the universe with us. Standing unprotected on Mars would be one of the shortest experiments in human survival. Yet, the fascination with this hostile world has never faded. Scientists, engineers, and dreamers all wonder the same thing: could humans adapt to such an unforgiving environment? And if so, for how long? To understand this, we need to go beyond the first few deadly minutes and explore what Mars does to the human body over time. Let's start with atmosphere and pressure, the invisible killers. On Earth, we live under the constant weight of about 14.7 pounds per square inch of pressure at sea level. This pressure keeps our bodily fluids in liquid form and allows our lungs to absorb oxygen. On Mars, that pressure is less than 1% of Earth's, comparable to standing at an altitude of 30 kilometers above Earth, higher than any mountain, higher even than commercial planes fly. At that level, human bodies simply aren't designed to function. The air molecules are so far apart that breathing them is pointless. Even if you filled your lungs with pure oxygen, the lack of pressure would make gas exchange nearly impossible. You would suffocate, not because oxygen doesn't exist, but because your body can't take it in. This is why space agencies insist on pressurized suits. Without one, Mars is effectively the same as space. And yet, knowing this, researchers have conducted countless studies to imagine what would happen if a person were accidentally exposed. NASA scientists point to real-world accidents. In 1965, a technician at Johnson Space Center was accidentally depressurized while testing a spacesuit. Within seconds, he lost consciousness. His last memory was of the saliva on his tongue boiling away. He survived only because pressure was restored in time. That's the kind of reality Mars offers: unforgiving, immediate, and merciless. But what if, somehow, you could overcome the suffocation problem? Suppose we gave you a small oxygen tank and mask, just enough to breathe, but no protection from the environment otherwise. Would survival improve? The truth is, only slightly. The thin air and lack of pressure would still wreak havoc on your body. Water in your eyes and mouth would evaporate almost instantly. Your blood vessels near the skin would burst from pressure differences. And the cold, let's not forget the cold, would freeze you in hours, if not minutes, once your body's heat escaped. And yet, scientists remain obsessed with survival scenarios. That's because Mars is not just a place of death, it's also a place of opportunity. If humans could solve these obstacles, Mars might one day be a second home. But before that dream, we must face the nightmare. Another danger lies beneath your feet: the soil itself. To the naked eye, Martian soil looks like desert sand, dusty and red, shaped by windstorms that rage across the planet. But chemically, it's laced with perchlorates, salts that are highly toxic to human health. On Earth, perchlorates are used in rocket fuel and explosives. On Mars, they're everywhere in the soil. If ingested, they interfere with the thyroid gland, damaging metabolism. Even touching the dust over long periods could be harmful. Scientists at NASA's Jet Propulsion Laboratory have tested Mars soil analogs and found that growing crops in untreated Martian soil would be almost impossible without careful removal or neutralization of these chemicals. Now think about storms. Mars is famous for its planet-wide dust storms. Unlike hurricanes on Earth, these storms aren't violent because the air is too thin to carry strong force. You wouldn't be blown away like in a sci-fi movie. But what makes them deadly is their duration. Some last for months, covering the entire planet in a reddish haze. Imagine being stranded during one of these storms with no power from solar panels, no visibility, and dust clogging every machine you rely on. Astronauts would have to survive in complete darkness, temperatures dropping, radiation exposure increasing, and a creeping silence all around. Radiation itself deserves more attention here. On Earth, we take safety for granted. The atmosphere and magnetic field shield us from cosmic rays, high-energy particles traveling close to the speed of light, blasting through space from distant supernovae, and the Sun. Mars offers no such shield. Astronauts on the International Space Station already experience higher radiation than we do on Earth, and even that is considered risky for long-term missions. On Mars, the surface radiation dose could increase cancer risks dramatically, weaken immune systems, and even affect cognitive function. Some researchers suggest humans on Mars might need to live underground, shielded by meters of soil or rock, to survive long-term. This brings us to food and water. Without help, you'd have none. And unlike Earth's deserts, where water can sometimes be found underground or in plants, Mars provides almost nothing usable. Yes, water exists in the form of ice, buried beneath the surface or at the poles, but without tools, you can't access it. Even if you managed to dig it out, the extreme cold would make it nearly impossible to use without technology. Dehydration would kill you within days, long before starvation set in. But starvation is also inevitable. On Mars, nothing grows naturally. The lack of oxygen, the toxic soil, the absence of liquid water, and the freezing temperatures mean that no plant or animal life can survive. Even microbes struggle. Experiments simulating Martian conditions have shown that Earth bacteria exposed to Mars-like radiation and cold die off quickly. That means if you were left with no supplies, your chances of finding food are zero. Yet, despite all of this, space agencies are preparing humans for Mars. Why? Because every obstacle, no matter how terrifying, has a scientific solution. Engineers design habitats with thick shielding, airlocks, and life support systems. Biologists study hydroponics and genetically engineered plants that might grow in controlled Martian greenhouses. Chemists explore how to extract oxygen from the carbon dioxide-rich atmosphere using machines like MOXIE, tested on the Perseverance rover. Every small success brings us closer to making Mars survivable, not for minutes, but for years. But let's return to the original question: how long could you really survive on Mars without help? Minutes at best. Perhaps a little longer with partial assistance, like oxygen supply. But the truth is, Mars does not forgive mistakes. It doesn't allow humans to improvise like we might in a desert or at sea. On Earth, survival stories exist because nature provides some resource to cling to. On Mars, nature provides almost none. You either have technology, or you die. So far, we've looked at the physical dangers of surviving on Mars without help: the lack of oxygen, the freezing temperatures, the toxic soil, and deadly radiation. But even if, somehow, you were given the bare minimum to stay alive, say a small supply of oxygen, or a temporary shelter, the next challenge might surprise you. Because survival isn't only about the body. It's also about the mind. Human beings are social creatures. We are built for interaction, for communication, for the rhythms of day and night that Earth provides. On Mars, you'd lose all of that instantly. The sun rises and sets, yes, but the sky is dimmer, tinted in red and butterscotch. Days are 24.6 hours long, close to Earth's, but the absence of familiar patterns, the sound of birds, the presence of plants, the hum of life, creates a profound psychological void. Astronauts who've lived in isolation studies on Earth describe the crushing silence and monotony as one of the hardest challenges. Now imagine that silence stretched across an alien desert where you are the only living thing for millions of kilometers. NASA has already studied this problem in detail. At the HIC's facility in Hawaii, crews live in Mars-like isolation for months, simulating the psychological effects of long-term missions. Their reports reveal stress, irritability, depression, and even breakdowns when confined to harsh environments with limited contact. The difference is, they had food, oxygen, and communication. Strip those away, and loneliness becomes not just emotional, it becomes fatal. Human minds, deprived of hope and connection, deteriorate quickly. But let's say you're stronger than most. Let's imagine you somehow keep your mind focused, determined to push your body as far as possible. What then? Could you last hours? A day? Maybe more? To answer this, scientists have modeled scenarios of partial survival. If you had oxygen only, you might extend your life by hours, but eventually, dehydration, radiation, and cold would overwhelm you. If you had shelter only, you'd suffocate quickly without oxygen. If you had food and water only, you'd still die within minutes because breathing is the most immediate need. Each missing piece guarantees failure. That's how extreme Mars is. Unlike Earth, there is no room for improvisation. On Earth, survival experts can light fires, find rivers, build shelters. On Mars, there are no fires, no rivers, no forests. You are utterly dependent on technology. Let's bring in the voices of real scientists. Dr. Robert Zubrin, founder of the Mars Society, has often said that while Mars is dangerous, it is also the closest thing we have to Earth. It has seasons, a day length similar to ours, polar ice, and gravity strong enough to allow walking and running. But Zubrin also emphasizes, without technology, Mars is instantly lethal. NASA scientist Chris McKay has described Mars as on the edge of habitability. It tempts us with the possibility of life but punishes us if we underestimate it. And then there's radiation. Astronaut Scott Kelly, who spent a year aboard the International Space Station, spoke often about the toll of radiation and microgravity. Even in Earth's orbit, with some protection from our magnetic field, his body suffered muscle loss, immune suppression, and vision changes. On Mars, unprotected, these effects would be magnified dramatically. Within hours, cells would begin to break down. Within weeks, cancer risks would rise. Within months, the brain itself could be damaged by cosmic rays. Without shielding, survival is measured not in years, but in days and weeks. Dust poses another insidious threat. Mars dust is not like the dust in your home. It's sharp, electrostatically charged, and clings to everything. Apollo astronauts who walked on the Moon experienced lunar hay fever when moon dust got into their suits and habitats, irritating their lungs and eyes. Mars dust would be even worse. Its tiny particles could cut into lung tissue and carry toxic perchlorates deep into the body. Even with oxygen, breathing dust-laden air would shorten survival significantly. Let's test a thought experiment. Suppose you were stranded on Mars with nothing but an oxygen tank strapped to your face. No suit, no protection, just oxygen. What happens? In the first few minutes, you'd breathe, but your blood would still boil from the low pressure. Your body fluids would evaporate. You'd feel intense swelling in your skin and eyes. Within an hour, the cold would steal away your body heat, and frostbite would begin. By the second hour, dehydration would become critical, and your oxygen tank wouldn't save you. You'd collapse, unconscious, long before the tank ran out. Survival time, less than 2 hours. Now change the experiment. What if you had a pressurized shelter with no oxygen supply? You'd suffocate within minutes. What if you had oxygen and shelter but no water? You might survive for 2 or 3 days, dehydrating rapidly in the dry atmosphere. What if you had oxygen, shelter, and water, but no food? Then perhaps 2 to 3 weeks, at most. Mars doesn't forgive missing essentials. Each factor, oxygen, pressure, water, food, radiation shielding, is like a pillar. Remove one, and the whole structure collapses. This is why real Mars missions are designed with such precision. The margin for error is zero. Spacecraft, habitats, rovers, and suits are engineered to protect against every threat simultaneously. Because scientists know that on Mars, you can't afford failure. Unlike on Earth, there's no rescue team a few hours away. Mars is tens of millions of kilometers from Earth. Communication alone takes up to 20 minutes one way. If something goes wrong, you're on your own. And here's the most haunting reality: even if you survived the physical threats for a while, the psychological weight of knowing you're utterly alone would be crushing. Astronauts on the ISS often look down at Earth and feel comforted by seeing home below them. On Mars, there would be no such comfort. The Earth would be just a tiny star in the sky, too far to reach, too far even to hope for rescue. That loneliness is as deadly as the thin air. NASA has long acknowledged this, which is why so many Mars analog studies focus not just on technology, but on human behavior. At the Mars Desert Research Station in Utah, volunteers simulate Mars missions for weeks. They wear spacesuits, eat dehydrated food, and limit communication. The lessons are clear: cooperation, discipline, and psychological resilience are just as critical as oxygen tanks and radiation shielding. Without them, missions fail, even here on Earth. So when we ask, how long could you really survive on Mars without help? The sobering truth is minutes. A few, at best. With partial supplies, perhaps hours. With more, maybe days. But without a fully designed support system, long-term survival is impossible. And yet, that doesn't stop humanity from dreaming. Elon Musk talks about building cities on Mars. NASA plans to send astronauts in the 2030s. Private companies, space agencies, and scientists all share one vision: that someday, humans won't just visit Mars, but live there. The paradox is clear. Today, Mars is lethal. Tomorrow, it could be our next home. Before we move forward, let me remind you, if you're fascinated by these deep, fact-based explorations of space and survival, make sure to subscribe to Starsky Science. We bring you the stories NASA and scientists are uncovering, told in a way that connects directly to you. Don't miss the chance to be part of our growing community of space explorers. Billions of years ago, Mars may not have been the deadly planet we see today. In fact, scientists believe ancient Mars could have looked surprisingly familiar. Rivers carved valleys, lakes filled craters, and oceans stretched across its northern hemisphere. If we had landed there back then, the question of survival might have been very different. Instead of suffocating within minutes, we might have found breathable air, drinkable water, and even the conditions for life. So, what happened? Why did Mars transform from a promising world into a barren wasteland? To answer that, scientists have pieced together clues from orbiters, rovers, and meteorites that fell to Earth. The evidence points to one catastrophic change: Mars lost its magnetic field. On Earth, our magnetic field is generated by the motion of molten iron deep in our planet's core. That field shields us from solar wind, a constant stream of charged particles blasting from the sun. Without protection, solar wind can strip away a planet's atmosphere. This is exactly what happened to Mars. At some point over 4 billion years ago, Mars' core cooled and solidified. Without a strong magnetic field, the solar wind tore its atmosphere apart. Over time, oceans evaporated, rivers dried up, and the planet became the dry, cold desert we see today. NASA's MAVEN spacecraft, orbiting Mars since 2014, has directly observed this process in action. It measured how solar particles continue to steal away bits of the Martian atmosphere even today. This slow leak explains why the air is so thin, why humans suffocate instantly if they try to breathe there. It also explains why liquid water can't exist on the surface for long: it simply evaporates or freezes. But here's the fascinating twist: ancient Mars may have been far more habitable than early Earth. Some scientists propose that Mars could have supported microbial life billions of years ago, maybe even before life started on our own planet. Imagine that, life might have begun on Mars first. If so, could traces of it still exist underground, hidden from radiation, clinging to ice pockets where water remains? That question drives much of NASA's exploration today. Now, let's return to the idea of human survival. If ancient Mars had oxygen, water, and a thicker atmosphere, survival might have been possible without any help. Imagine stepping out of a spacecraft 3 or 4 billion years ago. You might have breathed Mars air, felt rain on your skin, and seen rivers flow across its landscape. But fast forward to today, and all of that is gone. The Mars we face now is like a ghost of its former self. This leads scientists to wonder, could we ever restore Mars to its former habitable state? This idea is known as terraforming, transforming an entire planet to make it Earth-like. It sounds like science fiction, but serious researchers have studied it. Some propose releasing greenhouse gases to warm Mars, melting its ice and releasing hidden carbon dioxide to thicken the atmosphere. Others suggest building giant orbital mirrors to reflect sunlight down onto the surface. A few even imagine importing ammonia-rich asteroids to kickstart a thicker, warmer atmosphere. But here's the reality check: terraforming Mars is a project that would take centuries, maybe millennia. The technology required is far beyond our capabilities today. And some scientists argue it may not even be possible, since much of Mars' atmosphere was lost permanently to space. Without a magnetic field, any attempt to rebuild the air might just be stripped away again. Yet, the idea persists because humans are natural dreamers. We see Mars not just as a barren rock, but as a canvas for imagination. Could future generations walk there without suits, farm crops under open skies, and build cities? Or is that a fantasy we must accept will never happen? While terraforming may remain out of reach, there are smaller-scale solutions that scientists consider more realistic. For instance, building underground habitats protected from radiation, using local Martian resources to produce oxygen and fuel, and creating sealed greenhouses for crops. These ideas don't make Mars Earth-like, but they make Mars livable, at least for those willing to adapt. But think about this: if Mars once had conditions similar to Earth, does that mean it also once had life? If so, what does that tell us about survival, not just for humans, but for life itself? NASA's Perseverance rover is currently searching for fossilized microbes in Jezero crater, a place that once held a lake. If it finds evidence that life existed on Mars, it would mean the universe might be filled with life, because it started on 2 neighboring planets. And if life could survive ancient Mars, maybe humans could survive future Mars, if we learn how to build the right environment. This possibility changes the survival question completely. Maybe it's not about surviving without help forever. Maybe it's about learning from ancient Mars, applying science, and creating new strategies for survival that allow humans to thrive where nature says we shouldn't. The red planet has always tested human imagination. From early telescopic observations in the 1800s to the first robotic explorers in the 20th century, Mars has been both feared and admired. We see it as a mirror of ourselves, a planet that once had potential but lost it. And now we ask, could we bring it back? Could we give Mars a second chance, and in doing so, give humanity one too? Before we move forward, let me ask you, the viewers of Starsky Science, an important question. Backhand index pointing right. If you had the chance to live on Mars in a sealed habitat, knowing the dangers, would you go? Or would you prefer to stay safely on Earth? Tell us your thoughts in the comments below. We'd love to hear your perspective. The human body is a masterpiece of evolution, but it's a masterpiece designed for Earth. Gravity, air pressure, sunlight, even the bacteria in our environment, they all shaped us into what we are today. Take that masterpiece and drop it onto Mars, and you begin to see cracks form almost immediately. Because surviving on Mars isn't just about breathing. It's about whether your body and mind can handle a world that breaks the rules of biology. Let's start with gravity. On Earth, every step you take, every beat of your heart, every breath you draw is influenced by gravity's pull. Mars, however, only has 38% of Earth's gravity. That means if you weigh 70 kilograms on Earth, you'd feel like you weigh just 26 kilograms on Mars. At first, that might sound like a dream: lighter steps, higher jumps, less strain. But over time, low gravity isn't a blessing. It's a curse. Astronauts on the International Space Station have shown us what happens when the body lives without strong gravity. Muscles weaken. Bones lose density, becoming fragile and brittle. Blood doesn't flow the same way, it pools differently, which can lead to dizziness and changes in vision. Some astronauts return to Earth unable to walk properly without rehabilitation. And keep in mind, they spend months, not years, away from gravity. On Mars, colonists might live there for decades. NASA studies suggest that in Martian gravity, bones could lose mass at nearly the same rate as they do in microgravity. That means fractures and osteoporosis would become serious risks. Muscles, too, would atrophy unless humans constantly exercised. And what about the heart? The cardiovascular system evolved to push blood upward against Earth's pull. On Mars, that strain is reduced, but the body adjusts in harmful ways. Heart muscles weaken, blood volume shrinks, and circulation becomes less efficient. Over years, this could be life-threatening. Now let's add another invisible enemy, radiation. On Earth, we're protected not only by a thick atmosphere but also by a strong magnetic field. Mars has neither. Cosmic rays and solar radiation bombard the surface constantly. For humans, this means DNA damage, faster aging, and higher risks of cancer. In fact, NASA estimates that astronauts on a Mars mission could absorb radiation doses far beyond the recommended lifetime limit for workers on Earth. One proposed solution is to live underground or inside thick shelters built with Martian regolith. A few meters of soil could block most radiation, protecting colonists. But here's the problem: survival without help doesn't include these safety nets. If you walked outside, even in a basic habitat without shielding, your cancer risk would skyrocket. Radiation doesn't kill instantly, but it silently erodes health, increasing the chances of long-term illness. But survival isn't just physical, it's psychological. Imagine living on a planet where the sky is pinkish red, the horizon empty, and the landscape endless desert. No forests, no oceans, no sounds of birds or rain. Just silence, dust storms, and the knowledge that one mistake means death. The psychological strain of isolation is enormous. Astronauts in space stations already face stress, anxiety, and even depression despite having regular contact with Earth and each other. On Mars, the delay in communication, up to 22 minutes each way, makes conversations with Earth painfully slow. Loneliness would be amplified, and conflict within small groups could become dangerous. Humans are social creatures. Without the richness of Earth's environment, many might struggle to keep their sanity. To understand this better, scientists have conducted analog missions here on Earth. Projects like NASA's HICs in Hawaii or Russia's Mars 500 put volunteers in confined habitats for months or years, simulating Martian living conditions. The results show how boredom, stress, and interpersonal tension quickly build. Imagine years of that, with no escape, no fresh air, no sunlight. Could the average person endure it? Comparing life on Mars with life on the ISS is useful here. On the space station, astronauts live in microgravity, eat prepackaged food, recycle their air and water, and stay in constant contact with Earth. Mars would share some of these challenges, but with extra layers of danger: gravity that weakens instead of strengthens, radiation that constantly threatens health, and a complete lack of rescue options if something goes wrong. And here's the harsh truth: even if you somehow survived the lack of oxygen and cold, your body would slowly break down. Bones fragile, muscles weakened, immune system suppressed, mind strained. Survival on Mars without help isn't just about hours or days. It's about whether you could survive months or years while your body quietly deteriorates. This leads to a bigger question: should we even try to live on Mars permanently, or should Mars only be a place for exploration and science? Some experts, like Robert Zubrin, founder of the Mars Society, argue that humans must go to Mars to ensure our survival as a species. Others, however, warn that Mars might be a place where humans can never truly belong, at least not without massive technological support. But here's something fascinating: scientists have discovered that some life forms on Earth can handle conditions that would kill humans instantly. Tiny creatures called tardigrades, also known as water bears, can survive intense radiation, freezing, and even the vacuum of space. If life like this can endure, could humans one day be genetically engineered or medically enhanced to handle Mars too? The idea may sound extreme, but future survival could depend not just on habitats and technology, but on changing ourselves to adapt. And that brings us to another hidden danger: immune system suppression. In microgravity, astronauts' immune responses weaken, making them more vulnerable to infections. If the same happens on Mars, a small cut or illness could become life-threatening. With limited medical supplies, colonists might struggle to treat even common conditions. Survival without help? Nearly impossible. All of this shows one undeniable truth: Mars is not simply another Earth. It is an alien world that breaks the very foundation of what our bodies and minds need to survive. Without help, our chances are not just slim, they're virtually non-existent. But humans are problem solvers. We don't stop at impossible. We build machines, invent medicines, and design shelters. We dream of solutions. And perhaps, one day, those solutions will make Mars not just a place to visit, but a place to live. And once again, before we move on, let me remind you, if you're enjoying this deep dive into Mars survival, don't forget to subscribe to Starsky Science. Your support helps us continue bringing you fact-filled space documentaries that challenge the imagination. If oxygen is the first barrier to survival on Mars, then food and water are the second. Because once you've managed to take your first breath on the red planet, the next question is, how do you keep eating, drinking, and sustaining your body day after day in a world that offers almost nothing? Let's start with water. Mars is a desert world, but not completely dry. We know from orbiters and landers that ice exists beneath the surface, especially at the poles and in some mid-latitude regions. The Phoenix lander in 2008 actually dug into the soil and exposed chunks of water ice that sublimated into vapor. Later, the Curiosity rover found evidence of brines, salty liquid water that may exist temporarily under certain conditions. But here's the catch: this water isn't clean. It's often locked in permafrost, mixed with toxic chemicals like perchlorates. Drinking it directly would poison you. To survive, humans would need complex purification systems to extract usable water. And without help, none of that technology would exist. Now think about food. On Earth, farming relies on nutrient-rich soil, liquid water, and a balanced atmosphere. Mars has none of these. The soil, technically regolith, is filled with dust and sharp minerals that damage lungs if inhaled. It's also contaminated with perchlorates, which are harmful to plants and humans alike. And without an atmosphere to provide carbon dioxide and protect against radiation, open-air farming is impossible. So, could you grow food on Mars at all? The answer is yes, but only in sealed habitats, greenhouses, or underground farms. Scientists have already experimented with growing plants in simulated Martian soil. Surprisingly, many crops like potatoes, lettuce, and wheat can grow if the soil is treated and supplemented with nutrients. NASA even worked with the International Potato Center to test potatoes under Mars-like conditions, inspired by the movie The Martian. But even here, survival without help falls apart. Plants need protection from radiation, consistent warmth, and purified water. You would need advanced infrastructure to make farming sustainable. Without it, starvation becomes inevitable. What about hunting or foraging? On Mars, there are no animals, no fish, no forests, just endless rock and dust. The entire concept of food gathering collapses. Humans would be completely dependent on what they brought with them or could manufacture artificially. Some researchers propose using microbes or algae as a food source, since they can grow more easily and convert resources like carbon dioxide into oxygen and biomass. But again, these require controlled environments that don't exist naturally on Mars. Now consider energy. Even if you solved water and food, how would you power life support systems, lights, heaters, and farms? Mars receives less sunlight than Earth, about 43% as much. Dust storms can last for weeks or months, blocking solar panels almost completely. The Opportunity rover famously lost contact after a massive dust storm in 2018. Without a backup power source, humans would face total darkness and freezing cold. Nuclear power is one option NASA explores, but surviving on Mars without help rules out advanced reactors. This leads us to a deeper truth: the human body consumes calories not just for movement, but for survival itself, keeping warm, breathing, digesting. On Mars, the extra cold means even more calories are required to maintain body heat. Yet with no food sources, starvation would set in much faster than on Earth. Let's add one more challenge: nutritional balance. Even if you somehow grew one type of crop, like potatoes, you'd still lack critical vitamins and proteins. Long-term survival requires variety, grains, vegetables, protein sources. On Earth, our diets are supported by vast ecosystems. On Mars, you'd be trying to replace that with a handful of plants in a greenhouse. The margin for error is razor thin. There's another overlooked problem: gravity and digestion. In reduced gravity, the way food moves through the body changes. Astronauts in microgravity sometimes experience nausea, slower digestion, and even changes in nutrient absorption. On Mars, with only 38% gravity, we don't fully know how human biology will handle it. Could we eat normally? Or would even our stomachs rebel against the alien environment? And what about long-term farming cycles? Mars has seasons, but they last nearly twice as long as Earth's. A Martian year is 687 Earth days. This means adjusting crops to long, cold winters and unusual day-night cycles. The Martian day, called a sol, is only 40 minutes longer than Earth's day, which is manageable. But the overall climate swings could devastate fragile farms. Without advanced systems, farming would be a losing battle. Some scientists propose closed-loop life support systems, where plants, microbes, and humans form a cycle. Humans exhale carbon dioxide, which plants use for photosynthesis. Plants produce oxygen and food, which humans consume. Waste is recycled into nutrients. In theory, this could sustain life indefinitely. But here's the flaw: achieving a perfectly balanced loop is nearly impossible without constant adjustments and technology. Even on Earth, attempts at sealed biospheres, like Biosphere 2 in Arizona, struggled to maintain balance. On Mars, the difficulty would multiply. This brings us back to the brutal simplicity of the original question: how long could you survive on Mars without help? Without water purification, starvation might arrive within weeks. Without farms or food supplies, maybe months. But without the technology to maintain a cycle of resources, the body would eventually collapse. Every system, air, water, food, power, is interconnected. Remove one piece, and the chain of survival breaks. The irony is this: Mars has everything in trace amounts: water, carbon dioxide, soil, even sunlight. But nothing is in the right form for direct human use. To survive, humans would need to reshape those resources, forcing an alien world to meet Earth's requirements. Without help, Mars simply says no. Still, these challenges inspire new solutions. NASA and private companies are developing in-situ resource utilization, ISRU, using local materials to support survival. For example, machines that pull oxygen from carbon dioxide, extract water from ice, or turn regolith into building bricks. The Perseverance rover has already tested a device called MOXIE that successfully produced oxygen from Mars' atmosphere. These technologies hint at a future where survival becomes possible, not alone, but with the right tools. But as it stands today, survival on Mars without external support is a puzzle with missing pieces. Food, water, and energy all fail when stripped of technology. And that reality makes the idea of living naturally on Mars almost impossible. Imagine standing on the surface of Mars, and the horizon begins to disappear. The red sky grows darker, the sun fades into a dim glow, and fine dust fills the air until you can barely see your own hands. On Earth, this would be a passing storm. On Mars, it could last for weeks, even months. And once it begins, survival becomes a race against time. Mars is famous for its dust storms, the largest in the solar system. Unlike the storms on Earth, which might cover a region or a continent, Martian storms can grow until they wrap around the entire planet. One of these global storms in 2018 brought an end to NASA's Opportunity rover, which had been exploring Mars for nearly 15 years. Its solar panels were smothered by dust, cutting off power. The storm lasted so long that the rover never woke up again. For humans, the danger is even greater. These storms don't just block sunlight, they plunge the planet into freezing darkness. solar power drops, temperatures fall, and visibility shrinks to near zero. The fine dust itself is sharp, like powdered glass. It gets into machinery, clogs air filters, and coats every surface. Breathing it would be deadly, since Martian dust contains toxic perchlorates and could shred the lungs. And yet, here's the strange truth: Martian storms aren't violent like hurricanes on Earth. The air is so thin that even in 100 km/h winds, the force would feel like a gentle breeze. The real danger isn't impact, it's suffocation, contamination, and starvation as systems fail under the dust. Now, let's talk about temperature. Mars is cold, colder than Antarctica. The average temperature is about -60 degrees Celsius, but it can plunge to -125 at the poles. Even at midday near the equator, it might only reach a few degrees above freezing. Without proper protection, a human would freeze solid. Skin exposed to that cold would be damaged within seconds, and the lungs, trying to inhale thin, icy air, would seize. Unlike Earth, Mars has no thick atmosphere to trap heat. When the sun sets, the ground releases its warmth instantly, and the temperature plummets. Nights are brutally cold. Even habitats would need constant heating, demanding precious energy. Without it, hypothermia would end any chance of survival long before starvation or dehydration did. Mars also experiences seasonal changes because its axis is tilted, similar to Earth's. But the seasons are far more extreme. Winters are longer and colder, summers shorter and unpredictable. During some winters, carbon dioxide from the atmosphere freezes at the poles, forming dry ice caps. This means the already thin atmosphere grows even thinner. For a human, this makes breathing completely impossible, not that it ever was without help. These natural forces, dust, cold, thin air, combine into a relentless cycle of hostility. To see how severe they are, we can look at Mars exploration history. In 1971, NASA's Mariner 9 arrived just as a planet-wide storm engulfed Mars. For weeks, the spacecraft could barely see the surface. Imagine a storm so vast that an entire planet vanished into a haze. In 2018, the Opportunity rover fell silent after a dust storm blocked sunlight for 15 straight weeks. It never recovered. Even the more advanced Spirit rover struggled when dust accumulated on its panels, reducing power until it was stranded. The InSight lander, which studied Mars' interior, eventually died in 2022, not because of technical failure, but because dust slowly choked its power supply. If our best machines can't endure Mars weather indefinitely, how could a human survive without protection? And yet, Mars still surprises us with moments of calm. Sometimes the sky's clear, the pinkish horizon glows, and temperatures rise just enough for exploration. These short windows of peace might allow brief survival, if you had shelter and support. But the storms always return, as if the planet itself rejects intruders. There's another invisible danger tied to weather: atmospheric pressure. Even in calm conditions, Mars' air pressure is less than 1% of Earth's. It's equivalent to standing on a mountain 3 times taller than Everest. Without a pressurized suit, your blood would begin to boil, not because of heat, but because low pressure lets liquids vaporize at body temperature. This terrifying process, called ebullition, would swell your body and rupture tissues. You wouldn't survive more than a minute. Some might imagine building domes or shelters, but even they would face constant wear from dust storms, cold snaps, and pressure differences. Every seal, every wall, every filter would need perfection. Without it, disaster strikes. And consider this: even if you solved the engineering, there's no escape from Mars isolation. Earth and Mars align only once every 26 months for easy travel. That means once you're there, you're trapped for at least 2 years before a return window opens. In that time, dust storms, radiation, and cold will test every system, and every human. The harsh reality is this: Mars is not just another desert to be conquered. It's a planet shaped by forces Earth has long since tamed: thin air, frozen ground, endless dust. For humans, every storm, every cold night, every thin breath is a reminder that survival isn't just difficult. It's unnatural. And yet, this hostility makes Mars the ultimate proving ground. If humans can one day endure here, not just for hours, but for years, it would mean we've mastered survival in the harshest of environments. The planet is both executioner and teacher, showing us exactly what it takes to live beyond Earth. For centuries, humans have looked at the stars and imagined new worlds to conquer. The moon was our first step. Mars has always been the next dream. But the real question is this: should we simply visit Mars, explore its mysteries, and return, or should we dare to build a permanent human colony on a planet that seems determined to reject us? Colonization isn't just survival for hours or days, it's about thriving for generations. To imagine this, we need to think beyond spacesuits and temporary shelters. Colonization would mean entire cities under domes, underground tunnels filled with farms, children growing up never having walked on Earth, and humans slowly adapting to a new definition of home. But what would that really take? Let's begin with technology-driven adaptation. Right now, the most practical vision is building sealed habitats, powered by nuclear or solar energy, and sustained by recycling systems. These habitats would need to be pressurized like spaceships, producing their own oxygen, water, and food. Entire ecosystems, plants, microbes, even insects, might be imported to create balance. Instead of living on Mars, humans would essentially live inside Earth-like bubbles scattered across the Martian surface. This concept is called closed-loop life support. It's the same principle used on the International Space Station, but scaled up. Every drop of water is reused, every breath of air recycled. Even human waste is converted back into resources. The difference is that on Mars, unlike in orbit, colonists could supplement these loops by mining ice, refining regolith, and pulling gases from the thin atmosphere. Over time, technology would reduce dependence on supplies from Earth. But here's the challenge: systems fail. Filters clog. Machines break. Colonists would need constant repairs, and without resupply missions, breakdowns could become deadly. One leaky seal, one contaminated greenhouse, and an entire colony could collapse. This is why many scientists argue Mars should remain an exploration site only, not a settlement. Still, some dream bigger. Elon Musk, through SpaceX, envisions millions of people on Mars, building a backup civilization for humanity. His idea rests on scale. If enough people and resources are transported, Mars could reach a point of self-sufficiency. Critics, however, say this is dangerously optimistic. Transporting even a single kilogram to Mars costs thousands of dollars. Moving entire populations would require technology we don't yet have. But what if instead of reshaping Mars to suit humans, we reshape humans to suit Mars? This leads us into the realm of biological adaptation. Some scientists speculate that future colonists could be genetically engineered to withstand radiation, low oxygen, or weaker gravity. For example, adding genes from extremophiles, microbes that survive in Earth's harshest environments, might give humans better resistance to radiation. Or medical advances could enhance bone strength and muscle endurance to counteract low gravity. These ideas blur the line between science and science fiction, but history shows that technology often moves faster than we expect. Another possibility is cyborg adaptation, integrating humans with machines. Implants, exoskeletons, or internal systems could protect against the environment, regulate body functions, or even provide artificial oxygenation. Colonists of the future might look less like Earth humans and more like hybrids, half biology, half technology, tailored for life on Mars. But here's where philosophy enters the debate: at what point do we stop being human and become something else entirely? Is colonization worth transforming ourselves into a new species just to survive? Even without genetic engineering, humans would still adapt slowly over generations. Children born and raised in Martian gravity might develop taller, slimmer bodies, since weaker gravity would place less stress on their bones and muscles. But if those children ever return to Earth, they might struggle to walk, breathe, or even survive in our stronger gravity. In other words, colonization could create a permanent divide between Earth humans and Mars humans. Some scientists, like Stephen Hawking, argued that spreading to other planets is essential for the survival of our species. A single asteroid impact, nuclear war, or climate disaster could wipe out humanity on Earth. Colonizing Mars, therefore, isn't just an adventure, it's an insurance policy. Others counter that Mars is so hostile that investing in colonization might be less effective than protecting Earth itself. But there's also a psychological angle. Humans are explorers by nature. Settling Mars would satisfy our deepest instincts, to push boundaries, take risks, and seek new horizons. Even if it's costly, dangerous, and unnatural, the idea of planting roots on another planet appeals to something primal in us. Yet, here's the harsh truth for our original question: without help, colonization is impossible. A single person, dropped on Mars without supplies, would die within minutes. Even with supplies, survival is temporary. Colonization requires enormous cooperation, technology, and planning. It's the opposite of without help. And that's the irony: to make Mars livable for humans, we would have to throw everything humanity has, engineering, biology, medicine, and imagination, at the problem. Mars doesn't offer us a second home. We would have to build one there from scratch. So should we? Should we gamble resources, lives, and technology to settle a world that resists every step of the way? Or should we focus on keeping Earth, the only natural home we have, alive and thriving? That debate will shape the next century of science and exploration. Think about this for a moment. Humanity has always survived by adapting. We endured ice ages, crossed oceans, and climbed mountains that once seemed impossible. Now the challenge is no longer on Earth, it's 225 million kilometers away, on the hostile red deserts of Mars. Could we survive there? Could we truly build a future among the stars? The answers are beginning to emerge, and they are as breathtaking as they are terrifying. We've talked about the immediate dangers: the thin air, the deadly cold, the radiation, and the crushing isolation. We've explored the possibilities of shelters, domes, underground cities, and even genetic adaptation. But how close are we to turning these ideas into reality? Right now, across the world, scientists are testing pieces of Mars survival technology right here on Earth. NASA's Perseverance rover is running an experiment called MOXIE, which successfully turned Martian carbon dioxide into oxygen. Though small, it proved something groundbreaking: Mars could eventually provide its own breathable air. In Hawaii, desert regions, and even Antarctica, teams of scientists live in sealed habitats for months, simulating Mars life. They study the psychology of isolation, test farming techniques, and push recycling systems to their limits. Every small success brings us one step closer to true independence on another planet. Another breakthrough is 3D printing with Martian regolith simulants. Engineers have shown it's possible to use Martian dust, mixed with polymers or melted down, to create building blocks. This means future colonists could literally build homes from the planet itself, instead of waiting for shipments from Earth. Power is another critical factor. Solar panels are useful, but Mars dust storms can block sunlight for weeks. That's why NASA and private companies are exploring compact nuclear fission reactors, small, reliable power plants that could keep habitats running in any weather. And then there's food. Hydroponic farming, where plants grow in nutrient solutions instead of soil, has already succeeded aboard the ISS. Imagine vast underground greenhouses on Mars, glowing with artificial light, growing lettuce, potatoes, and maybe even fruit trees. One day, the first Martian-born child could eat a strawberry grown under the red planet's surface. But even with technology, the timeline is daunting. NASA aims to send the first humans to Mars sometime in the 2030s. SpaceX has promised bold timelines of establishing early colonies even sooner, though many experts believe this is overly ambitious. In reality, a small, semi-permanent base might appear within the next 30 to 50 years. A true city on Mars, self-sustaining, growing, thriving, could take a century or more. The truth is, survival on Mars without help is impossible today. Even with help, it will be one of the hardest challenges humanity has ever attempted. But history shows us something: what once looked impossible has often become inevitable. Flying, space travel, landing on the moon, all were once only dreams. Mars may be the same. And maybe, just maybe, the first person to set foot on Mars is alive right now, watching the stars, dreaming of a new world. So let's come back to our original question: how long could you really survive on Mars without help? The answer is minutes, maybe seconds. But with the help of science, cooperation, and generations of innovation, humanity's survival on Mars could stretch not into minutes, but into millennia. Before we end, I want to ask you something. If you had the chance, would you leave Earth behind and live on Mars, even if it meant never coming back? Tell us in the comments, I'd love to hear your thoughts. And if you enjoyed this deep dive into the science of Mars survival, don't forget to like this video, share it with your friends, and subscribe to Starsky Science for more mind-expanding explorations of our universe. Your support helps us bring you more fascinating, fact-based documentaries every week. Because the truth is, the story of Mars isn't just about survival. It's about the future of humanity itself.